Okay, we're going to try this again, going through cross-bridge cycling. So let me real quick view. Let's make this, okay, it's just like I want. Okay, so we're starting with tight binding here. Okay, and so let me write that just so we're clear. So when we start this phase, we've got tight binding or the rigor state. Okay, actin and myosin have just bound because there's calcium available, which moves troponin out of the, or which binds the troponin, which moves tropomyosin out of the way. So we've got this tight binding. Well, the next thing that happens in this process is that ATP, which is just floating around in here, comes and binds to the myosin head. Okay, and so when that happens, we come over to this side here, and so, whoops. And so now the myosin head is detached, okay? And so if we come to our cause and effect, like I talked about in class, the cause is ATP binds to myosin, and then the effect is that actin and myosin separate. Okay, and I forgot to put that we've got ATP here. Whoops, wrong color. Okay, so I've got my whoops, oh my gosh, sorry about this. Technical difficulties, separate. Okay, and so now we've got ATP attached. All right, so now that we've got ATP, what's gonna happen is we're gonna go from there to ADP plus phosphate plus energy. Okay, and so here's my energy that's exploding, and this is going to cause a change. All right, and so ATP converted into or broken down into ADP plus phosphate plus energy. Okay, and specifically this energy causes this to occur. So now we've got the myosin head bound, but it's cocked now, okay? And so it reattaches and then it cocks, probably in the reverse order. So the myosin head cocks and reattaches. Okay, so we've gone from here to here. And we've also got to be sure that we've got ADP plus phosphate attached here. Okay. And then we go from here down to here. And I know this looks a little messy. All right. So now we've got to go from that part to what's next. And so what happens here is that the phosphate, specifically the phosphate, will just leave. And so now I've got phosphate floating around here. And I've got the ADP all by itself. And so this causes something. So phosphate leaves. And so then what happens is we come over here. My myosin head uncocks, or we have what's called the power stroke. And so the actin moves this way towards the M line, and I forgot to put the M line and the Z line on here, but we're going to add those now. So over here, we're just going to say M, Z, Z, and M, Z. Okay, and so with this power stroke, what happens is we're increasing the overlap. Okay, so we've got increased overlap between actin and myosin. Okay, so that's what's going on here. All right, but when this is all going on, we've still got an ADP attached. Okay? And so then the next thing that happens is that this ADP just moves out here, so we've just got a lone ADP. And then ultimately, what happens is we go back to the first step. Okay, so the cause is ADP leaves. and then we go tight binding / rigor, which is our first step. Okay, and so then we go back to step 1. All right, and that is how this sliding filament theory or cross bridge cycling works.